let's go around the room here at Cranbrook and introduce everybody, starting off with this gentleman at the table up front.
Yeah, okay, that's Bob Tremblay.
Me?
Yeah.
Sure.
Oh, I'm with Kenny. And he's got here at the moment.
Partin.
Gerald Voorhees.
Tom Servanac.
Ken Lord.
Tom Hagan, radio astronomy coordinator.
Maria Bognar. Lois Cheney. Tommy. There's Tina Long.
Terry.
Fraser Johnson. Brian Fox.
Fabulous. Raise your hand if it's your first time attending. Excellent, excellent. How did you all find us? Just shout it out. Internet? Internet. Okay, wonderful, wonderful. Okay. So, we've had a number of personnel issues thanks to the storm. We've got a number of board members who are dealing with power outages, flooding, etc. I think raise your hand if you were affected by it. Yeah, not great. So,
Come back at it.
My fat ice cubes.
oh my God. Yeah. Okay. So, we'll keep things quick tonight. We've got two excellent talks queued up for you and a number of things to talk about outreach wise. So first off, the most important thing on the agenda is we are closing in on the date of the WASP picnic. WASP picnic is going to be 5 p.m. at Stargate Observatory on the 25th. That is the same date as our monthly open house. All are welcome. Bring a dish to pass. The club will be providing burgers, dogs, vegetarian alternatives to burgers and dogs, buns, condiments, water, and pop. And Mark Kedzier has signed up to be our grill meister for yet another year. Go, Mark. So we you can, in addition to yourselves and a dish to pass, bring what you would like to swap out. We are going to be having a low-key swap meet. So if you've got anything that you'd like to trade out, trade in, whatever, bring it along. And then cross your fingers that we have excellent weather to be able to allow for both a good picnic and then observing afterward. So any questions from anybody about the picnic?
Would you repeat what the staff is bringing?
We are providing burgers, hot dogs, buns, pop, and water. And condiments for the burgers and dogs. Anything else, chips, cookies, fudge, casserole, hot dish, what have you, that's collective responsibility. Yes, Dale.
Is there a policy regarding pets?
We welcome service animals. We do not welcome pets because pets and telescopes don't mix. So trained service animals only. Yes, Mark.
It starts on what time?
The picnic starts at 5. If you would like to volunteer, be there around 3:30 to 4 o'clock. But if you're just coming as a guest with your dish to pass and your stuff to swap out, 5 p.m. Yes, Mark.
What time do you expect the grill meister to have the burgers and hot dogs ready?
Whatever time he finds feasible given his arrival time. Okay, so let's make it a great picnic, y'all. We're hoping it'll be fantastic. As far as presidential stuff, that's the main one. Other than the call for a secretary, we still have a vacancy. Dale Teamy has been helping us get notes out so that y'all can see the minutes in the WASP like clockwork, but a formal secretary to be a 7th vote on the board, a tiebreaker in the event of a sticky vote would be a great thing. Contact me if interested. Our first vice president, Jonathan Cade, is currently on a plane for work headed to Seattle. He regrets not being able to be here tonight, and he says hi to y'all. He wants y'all to know that there are many slots open for next year. And next week at Macomb, we have Bob Tremblay on deck to do, what's the title, Bob?
Keeps astronomy, no man.
I think we can all get behind that one. All right.
Yeah,
There will be math.
that's here.
Okay. I will now turn things over to Riyadh, our second vice president.
Yeah, thank you, Diane. Hello, everyone. Um, our last open house was on June 27th. We were open from about 7:33 p.m. to roughly 12:45 a.m. We started out kind of cloudy and a little bit and hazy. Later on, the clouds moved away, but we stayed kind of hazy a little bit throughout the night. We had about 30 scouts and their parents that attended. We also had a number of visitors and members that attended the open house. So we still were able to use the 8-inch refractor to do some observing. We started out looking at Venus, then we looked at the moon. And later on, we looked at a couple of deep sky objects, but they were not really all that great because of the heavy haze that we had. However, we did look at some double stars, and double stars can punch right through the haze. It's no problem. We looked at Epsilon Lyrae, which is a beautiful double-double. And we also started using the astrometric eyepiece to try to measure some double stars. So we looked at Alberio to see if we can do some measurements. So we're going to need to calibrate the eyepiece, but it's in a working condition right now. We dimmed out. I was able to dim out the light a little bit, so it's not overpowering the stars. There were also a number of telescopes that were set outside the observatory on north side and south side. So we had a lot of activity actually out there. We had a few things that are already being repaired. Mark, thanks to Mark Kedzier for working on the dome to stop the leaks, and he has some plans to do some additional work to quiet it down and maybe improve how it works. Also, thanks to Pete for working on our wooden ramp in the front of the observatory on the west side. He improved it with better fasteners and new anti-slip pads. And thanks to everybody that helped out. Joe Toko's out there as well, and Tino's out there. They helped out with the crowds a little bit. So that was really a lot of fun. We had probably somewhere around 50 to maybe a little bit more people. So as was just mentioned, as Dan just mentioned, next open house is during the picnic. On the 25th, and I'll be out there probably about 3:30, 4 o'clock, and I'll go ahead and maybe open the dome and see if we can do some solar observing in the meantime. So that's all I have for now. Thanks.
Thank you, Riyadh. Hey, can you all still hear me? Dale, can you all still hear me? Okay, cool. We got a late-breaking text from Jonathan. He would like you all to know that if you want to give a talk, we have 2 openings still on the books for this year. One of them is October, Macomb. The other one is December, Cranbrook, for the long talk only. So if you are interested, email firstvicepresident@warrenastro.org and sign yourself up. Mark Miles, our treasurer, was one of the people that is got a lot going on tonight. So I wanted to say on his behalf, we've authorized the $500 to GLAC for astronomy at the beach. And I wanted to talk a little bit about the GoFundMe. I know some of you have already contributed. GLAC issued a call, that's Great Lakes Association of Astronomy Clubs, for a GoFundMe to the tune of $8,000. That raised some eyebrows among those of us who've participated in planning it in the past, since the budget used to be about $2,000 a year. Went over the books with their treasurer, and the tents that keep a roof over everybody's head at Astronomy at the Beach, rain or shine, now come in to the tune of more than $6,000. In other words, the tents alone cost GLAC what it used to be for 3 years of operational expenses. Hence the GoFundMe. So, and obviously astronomy clubs don't have it in the kitty to fund that all on their own. So if you see the link, it's legit. We've vetted it, and we wish Astronomy at the Beach good luck for this year because 6,000 is a lot. Also, if you are interested in serving on the planning board, they would love more participation from all of the clubs. I know Bob's been soldiering on for many a year now. So see Bob if interested in helping to plan astronomy at the beach. Okay. That takes us to outreach. We have quite a few events on the calendar now. We've got an event coming up at the end of this month. We're trying to work out the date, whether it's the 24th or the 25th, Lower Huron Metro Park. If you are interested in supporting an event at Lower Huron Metro Park, let me know. I'm trying to coordinate with the Lowbrows to get somebody down there because that is the same weekend as our picnic, and it's a bit outside our service territory.
Which part?
Lower Huron, down in Western Wayne County. That's easy for me. That's not easy for a lot of y'all. So, like Van Buren Township.
What city is it there?
I don't think it's in a city. Yeah, south of Belleville. It's considerably south of Belleville. We also have an event coming up at Tecumseh Library, which again is way to the southeast, but it's going to be a good event. We've hooked up with the Lowbrows on that one too. So they're going to be having telescopes. That will be in late September after Astronomy at the Beach. We've got an event coming up at the Belleville Library in October. So we've got a lot going on for the autumn. And of course, we've got 2 events coming up in right here at Cranbrook Institute of Science next month in August. One on the 12th, that's going to be a partial eclipse and a meteor shower. And then the follow-up eclipse happening on the 27th. So we'll get that details for both of those in the WASP next month, and we'll be passing around a sign-up sheet in August. So just keep all those in the back of your head because we've got plenty of requests coming in. Riyadh, are there any additional events at Stargate that we need to staff?
Not at this time.
Sounds good. All right. And then on to publications. Our publications director could not be here tonight, but we've got our award-winning editor here, and the WASP is out with another great lineup of pieces. If you want to participate, just email publications@warrenastro.org by the 28th of the month, and Dale will get it out. Dave, what's up?
Hey, hey there, how's it going? You hear me?
Yes.
Okay. Hey, so I have that dwarf committee, and I'm gonna hopefully try and use it tonight. We'll see how the skies do. But I want to make sure it's available for outreach, or if any of our members want to try and work with it for a little while. I don't want it to be just me. So if there's any members that are interested and checking it out and learning how to use it, that would be wonderful. And I don't know if I'll be able to make it to any of those outreach events, but we'd love for somebody to take it there because that's what they want us to do with it.
Very cool. Dave, the sound is a little watery. Could you just repeat the essence of that one more time?
Really? That's weird. Usually I'm setting a good mic. Still the same? No good?
A little better.
I can try a different mic. Hang on. Oh, microphone. Maybe a noise removal. How's that? Any better?
Yes.
Okay, so I have the Dwarf Mini that we got from Dwarf Labs, and I would like for my other member to, if they're interested, to check it out, play with it, learn how to use it, and then also somebody bring it to any of these outreach events and share it with everybody there. So I don't want it to be just me.
Very cool.
The two summarize what you said.
Yeah, could you type that in the chat so everybody can see it, Dave?
What did she say?
Just type it in the chat.
Type what, everything I said?
Yeah, the short version.
Oh, okay, sure.
That way we've got it in text.
Okay, cool.
Thank you. All right, any other outreach related news that before we move on to subgroup reports? Very good. Bob, I believe we have a solar report.
Yeah, Kelly, you bring me. Thank you.
Ready, just get the picture up. All right, so there is a monster coronal hole I call the Eye of Sauron there, smack in the middle of the sun, pouring solar wind out of it right towards us. So this is a picture taken from today. This is the sun in 211 angstroms. The solar wind is quiet. It's 1.33. Now it's odd because yeah, down a little bit. When the 1.33 there was like 4 when I started doing this presentation. It went back and it went way down. So down to the sunspots. Down the picture. Yeah, there you go. There are 8 numbered sunspots on the sun's face. There's a monster rotating out of view on the right side here. And there is something rotating into view over on the left side there that is, Noah says, poses a threat for X-class solar flares. So the next couple of days ought to be exciting. If that happens, expect aurora. Scroll down. This is a magnetogram of that sunspot rotating into view, so there's a heck of a magnetic field associated with it. Scroll down to the graph. That is a graph of the last 24 hours showing solar flares. We've had a couple C's and a couple M's, no big ones. We have a lot of coronal loops. The sunspot rotating out of view has this beautiful coronal loop associated with it, and that's rotating out of view. So, and now for something completely different. Scroll down that picture. You all, if you've heard me talk for any length of time at all, you know I'm addicted to Kerbal Space Program. Well, development on the spiritual successor to Kerbal Space Program called Kitten Space Agency is just going crazy, and they've introduced modular parts and storage. We'll scroll down. They've got docking working. Scroll down, and this is like the last week. They're doing volumetric clouds for solid rockets, so launches are going to look fantastic. The developers of this program, Kitten Space Agency, have made the app available for download free right now, and there's a new build every single day. You can donate to them too. I did. They want to make this available to schools so that they can get the app and teach aerospace science for free so that there's no money involved. So I'll be updating every once in a while on this, but that's it for solar and others.
Thank you, Bob. Riyadh, over to you for a double star update.
Yeah, so for the next time we get a chance to observe double stars again, hopefully maybe at the open house during the picnic, I'd like to continue to use the astrometric eyepiece and see if we can start to get a little better measurements and maybe do a calibration on the eyepiece. I also have a second eyepiece of my own, astrometric eyepiece that I've had since the kind of mid-'80s. I'd like to see if we can use that as well. It may be a little bit easier to use for people with glasses. So I'm hoping to bring that along with me as well. So maybe we'll have a few actual activities to do other than just look at beautiful doubles, which we will do anyways.
Very nice. And we've got Tom Hagen in the house tonight. Tom, do you have a radio astronomy update for us?
Yeah, another little project started. A big project, things. We got some pictures.
Oh, nice. So, let's see if we can get them on here.
Yeah. It's right here.
Go to it.
All righty. Well, thank you everybody for putting up with me. My latest project is making an attempt to detect a pulsar.
Oh my.
And why is this not opening?
Hmm.
Not sure. Yeah, for everybody's oops,
We gotta share this guy.
let's turn on the loop.
We need to share him on Zoom.
Come on. I know where you are. You may get there. I think screen one is probably one. What about the yeah, there, okay. Going sideways is kind of hard. Yeah. Oh, okay, now they can see it and we can't.
But they can see it.
They're seeing it on Zoom, we're not seeing it here.
Okay.
I need it.
There we go.
Okay. Get this. Move it. Yeah, well, look off to the side, does that mean?
Can you click anywhere in there? Can you try it?
Got us somewhere. Okay, there we go. Yeah, that's probably acceptable. Okay, I can maximize you. There you go. There you go. So you just. Yeah, hit the go button and you hit the loop button here too, so that loops if you can. Because only about 30 seconds or so. Okay.
Nice.
So a pulsar is a neutron star that can be detected using radio waves. And most people, I think, know that a neutron star is a collapsed version of a large star that's gone through a supernova event. And everything collapses down to a small ball, maybe 10 or 12 miles across, with the mass of the sun. These things are incredibly dense and hot. And they're rotating as the mass collapses into the center there. It rotates faster and faster and faster. And the one that I'm trying to detect turns about once every 0.7 seconds, or about 3 times every 2 seconds. The magnetic poles, as a rule, don't line up with the rotational axis, so they sweep around in these conical shapes. And if we just happen to be in line with the path of one of these cones from one of the two poles, we can get a radio burst. And if you know the rotation rate and the pulse width, you can actually point it at the object and detect it. So you have to have some information ahead of time for, for smaller telescopes like the one I'm using.
What's the frequency range you're looking at?
I'm looking at in the 400 megahertz range. And this is where pulsars tend to be about the brightest. And I'd like to display that picture. Let's see here.
I think we need to stop share and then share again.
So I'm looking at the Google here, and it's saying that pulsars put out between 100 megahertz and 3 gigahertz. And you're comfortably within that range. Now,
Yeah.
is that related to the size of your telescope?
Well, yeah, I'm in the shooting for frequency in the low 400 megahertz range, and we get this to display. Why is this?
Drag it.
Oh, okay. I can't do that. I'm not good with these things at all. So 400, the antenna is large.
Yeah.
Okay, this is the size of the antenna. That's my buddy Ken Redcap. He's been helping me with it. And the antenna consists of 3 reflecting panels. Somebody turn the mic off, please. All right. Anyway, these panels they form what's called a 3-corner reflector, and these are 2 meters square on the side. My problem is that I can't leave this set up in my in my condo association. I can't even put it up. So
HOA have problems with that?
yeah, just a little bit.
It's right here. There, that works too.
Got a mouse. Oh, there it is. So here it is in transport mode. So we started using this guy. We went to Ken's house and set it up there. You have to tip it up. We're facing north. The object is in circumpolar location. It's in the constellation Camelopardalis, I believe it's called. And the object culminates at about 78 degrees in altitude when you're looking due north. So you have to tip this thing up another 30 some odd degrees so that the beam lines up with the object as it drifts across. It drifts across in about 2 hours, given the beam size. And you collect data using software-defined radio and an application called GNU Radio. Here's my setup here. Just basically a laptop, and my the black box with the green marking on it is my software-defined radio. And then that goes off to the antenna, which I connect through a preamp to it, about a 23 dB preamp. And then after I've collected my data for about 2 hours, I run it through this software called Presto, and Presto is professional software that radio astronomers use to detect and search for unknown pulsars. And these graphs here are different statistical measures that show whether or not you've detected the pulse or not. This is my first attempt here, and it doesn't look very good. For comparison, this would be a good detection here. You see these very sharp pulses, and you see clear traces on the graphs, the various graphs. These are time versus phase, frequency, and then you get these two above here are combined to create the one in the lower right corner. So I'm continuing to work on my setups and everything, and trying to understand the software better too, because I'm really new to this. I'd be happy to have anybody step up and collaborate with me if this looks interesting at all. And if you know anything about statistics, that could be helpful too. And also could anybody, or does anybody know of a place where I could set this up for maybe a month or so and then do an experiment, different experiments, when the object passes through the beam? Any ideas, parks?
I know a place
Where?
way up in the Upper Peninsula.
Okay.
A whole bunch of friends of mine bought a valley that they filled with stamp sand. We call it the Desolate Wasteland Preservation Society, but it's literally flat stamp sand in the middle of nowhere.
And it has a good view to the north, I take it.
Okay. It has bugs like wouldn't believe, but
Yeah.
yeah. It's where I'm gonna be going later on.
How are you?
Summer.
I was gonna say, you might want to reach out to Jonathan about Dark Skies Alcona and see if that would be a good place to host it.
Where's this?
Alcona County.
Okay. Oh, way up there.
What about Stargate?
I was out there I did a quick RFI survey, and I noticed that there's a cell phone tower about 500 feet away over by the fire station. And there were like half a dozen RFI spikes in this 400 megahertz range coming from that thing. So I don't know about that. There are ways in this software you can actually delete spikes, so that might be a possibility too. That'd be obviously a pretty good choice. But anyway, that's what's going on, and give me a buzz if it looks interesting. You'd like to collaborate. I'd really appreciate it.
Awesome.
Yeah.
Thank you, Tom.
Place for you to set up in the Upper Peninsula. A buddy of mine bought part of a plot of land at an old Air Force base, and it's got a radio tower on it.
Yeah. It's not a cell phone tower, is it?
No. Actually, the guys that own the rest of that came and gave us a talk about the Mount Forest really.
Yeah, the problem is that this antenna doesn't move, so I just have to set it up. And every 24 hours, I can do it quick. So I have to be able.
All right. Well, we're past the bottom of the hour now, so I believe it is time for the first vice president, who's not here, to invite our short presentation speaker, who is here, up to the podium. Would you say so, Dale?
Which now?
You. Okay, so Dale Tammy is familiar to all of y'all. He joined the WAS in 2007. He started serving on the board all the way back in 2012, served on for 8 years in various capacities, and he's edited the WASP for 9 years, receiving the Mabel Stearns Newsletter Award from the Astronomical League in 2021. He also says he is the proud owner of 2 very nice recliners to aid in his armchair astronomy research, and he is here to tell us about our wobbly moon. Take it away, Dale.
Almost there. Let's stop this for a second. Oh, it got small again. I think we're there. Okay. Now this comes from a one of my armchair astronomer series from the 2020s, inspired by Gary Ross's talk on his search for the identity of the shining mountain that he spotted while observing the moon. Now, the article spanned issues May through December of 2020, with September being the issue with the libration column. You can find links to all the articles in the July History SIG column. Now, last May, Rick Hill took an image of the blue moon, conveniently coloring it for our amusement. Using my Virtual Moon Atlas app, I plugged in the time he took the image and got the ephemeris. Shown below are the libration variations, but what do those numbers mean? Now, what is the definition? Let's ask Mr. Webster. Here we go. Libration, an oscillation in the apparent aspect of a secondary body, such as a planet or a satellite, as seen from the primary object around which it revolves. Okay. Well, how does it work? When we look at the moon's disk in the sky, like in a full moon, it looks like we're looking at half of the moon, 50%. Not quite, because the moon's not quite spherical shape, we get only 44%. It is libration that takes us up to 59%, which isn't too shabby. Fun fact, it takes about 30 years to see all that extra 15%. Oh, are you getting a little mesmerized yet? Now, there's 4 basic types of libration. The variance in latitude is plus when it comes, when it tips from the north, or minus when it tips from the south, and it maxes out at 7 degrees, 54 minutes. In longitude, a plus designation means the east side, Mare Crisium, is tipping towards us, or a minus side, which would designate the western side, that's the Grimaldi side, and that maxes out at 6 degrees, 50 minutes. Now, diurnal and physical are less than 1% in any case, and don't figure in the calculations. And here, that's where the center of the moon wanders around it. And here, you see the area zoomed out. It's a tiny little spot on the moon that it's wobbling around.
Now, here's a simplified diagram of the mechanisms in play. We have the tilt of the moon's axis, which points in the same direction, irrespective of Earth. So while the moon faces us all the time, when it's facing the other side, it's tilted in another direction. So you have in one side, the north is tilting towards you, and you get around the other side, the south is tilting towards you. And there's a tilt of the moon's orbit relative to Earth, and this all plays into degrees of vibration that we benefit from. Now, the elliptical nature of the moon's orbit gives us the longitudinal variations. The moon rotates once a month, but that rotation speeds up and slows down with the track around the ellipse. Closer to the Earth, a bit faster. Further away, a bit slower. The result is we get a sneak peek over the western or eastern limb of the moon. And I look at that diagram and I say, well, I don't know how to explain it to anybody, so I did a little hand waving here and we'll go on. Now, when the moon rises, you are peeking around the leading limb. When it sets, you're looking around the trailing limb. And the result of that parallax, and at less than 1% effect, hardly worth the bother to calculate. And nobody has made a visual of the physical wobble. So we're not going to slide for that. Now, libration gives us, I'm going to have myself, here's a libration chart. This is showing the month of June, where the moon is forming an elliptical pattern around its extreme positions. Now, each month that goes by, this oval is going to change, is going to shrink, go bigger, go different directions, different axes. And like I say, 30 what odd years is going to cover the whole circle. Now, this is a Winkel triple projection, and it's an excellent example of illustrating how much more the moon is revealed to us. So you see the yellow lines are showing where the moon is visible to us at zero libration in any degree. The green lines is our maximum view. And that's a little misleading because like right here, the Mare Orientalis is going to show up as just a jagged line on the edge of the moon when it's tipped towards us. And here we go. Up here, we have Grimaldi and Kruger down here. And right here, this little dot is Burgius A. And Mare Orientali is like right smack dab in the middle around here and way over on the edge. So you got the Mare Orientalis complex here consisting of the Montes Cordillera, Montes Rook, and the Orientali Basin all on the edge. In fact, this very gray area here is probably the basin right there, right on the edge. Now, this is what the moon was doing at the start of the meeting. Using the Virtual Moon Atlas program, I plugged in the date and time, creating the view. You can see the latitude line is forming like an upward curve. The longitude line in the middle is forming a curve going off to the right. And the combination of the two is giving us negative libration numbers. And we can look at right here. There you go. We have libration in latitude and libration in longitude. So -251 and -652. Now, Rick Hill passed along links to a couple of programs that he uses. The Virtual Moon Atlas is one. You can download the app installer or order an SD card with the app and extra overlays. And you might want to do the ordering of that because Microsoft doesn't like me downloading the overlays. It says these are downloaded so seldom that Microsoft won't let me install them. I wrote to them, I says, I trust this program, let me do it. You know, they haven't answered. So I ordered the SD card. We'll see when it shows up because it's coming from France. And when Juke OS, his go-to program to double check what the virtual atlas delivered. So if he's got a question about some of the ephemeris numbers, he will load this on it and take a look-see. It has many features besides lunar, Jupiter observing being a rather obvious one. It's a planetary observation app is what it comes down to. And I have links to both programs in the presentation announcements on page 9 of the July WASP, another ad for the WASP. Now, librations create a lunar face that nods its ascent. Now, this was attributed to Antonin Reuchl, but who knows? It's a nice quote, just the same. Thank you, and please address all questions to my minion. And I hope this makes librations clear as Reuchl to you.
All right, you have a question, minion or no minion?
My minion is on a plane right now. Yes, Dale.
Has anybody figured out whether these various types of wobble are going to slowly diminish with time? Or were they bigger in the distant past, like a billion years ago? Has anybody, to your knowledge, looked into that?
Nobody has published any kind of extensive studies on libration. They just say, we got it. Here it is. This is what the moon's doing. Yeah. I have several lunar atlases, and libration just gets a passing nod, basically.
I understood that the moon is moving away from us
It is.
and relatively quicker state than we thought.
Well, you know what happens with the moon moving away? What happens is geometry kicks in. So the angle, when the moon's real close to us, the angle is greater. You're seeing less of the disk.
Right.
So libration might not be as helpful when it's closer. When it gets further, libration might be, showing us even more. But again, it's just the edges. And you look at the edges and they're just lines and stuff.
Actually, anything it's doing, this
Hmm?
is moving away. There's something being modified because of that motion.
Well, just the angle of the view,
Okay.
because if you're looking at a sphere very close, if you're like 2 inches from that sphere there, and you look at it, how much of the surface are you going to see? Your horizon is going to be very close. And the further you get away, the more of that globe you're going to see.
Okay.
Which is why when I hold the globe up, I says, that doesn't look like a full moon to me. Well, I'm holding it too close.
Thank you.
Thank you, Cal. All right, so it is now time for our bio break. So we've got limited quantity of snacks and treats and plenty of water up at the front of the room, and we will reconvene in just after 8 p.m. So, and I believe Ken had something he wanted to announce.
I did want to mention that tomorrow, at about 6 on Zoom, I will be giving a presentation on Carl Sagan, through Zoom with the Detroit Library. It'll start about 6 o'clock, probably be about an hour presentation.
So you see that.
Is this being kind of examined now?
All right, everybody, let's filter back to our seats. It is time for the feature presentation.
Here in stage, right?
Yeah.
Yeah.
All right, everybody, showtime. So tonight's featured presenter is Dr. Dale Partin, a familiar face to many of you. He is a Ph.D. from Carnegie-Mellon University. Until his partial retirement, he worked in advanced research in the auto industry. He has over 80 scientific publications, 38 patents, and is a fellow of the American Physical Society. He is an amateur astronomer with us, and he teaches astronomy at the Macomb Community College in Michigan. So, without further ado, Dr. Dale Partin.
Thank you, Diane. Can everybody hear me okay?
Not here, yeah.
How's that?
No.
A little bit better.
Testing, testing,
Not here, you, not here.
testing, testing.
Let's turn the master volume up.
Rita's not going to be.
Testing, testing. Can you all hear us? I think it's off. It's not making any noise.
Okay.
There we go.
Okay, try it. That sound okay?
That's better.
All right. Okay. The search for extraterrestrial intelligence. I look back through my records, and I first gave a presentation right here on this topic in 2006, 20 years ago. And I wound up giving an update on this topic every 5 or so years. And there are some fairly major things that have changed over the years. I now understand a lot more about why we have not detected radio signals from anywhere. That used to be well, we haven't searched in all directions and all frequencies kind of story. Surely we'll eventually find some signals. That's no longer the story. And whereas we knew almost nothing about how many planets stars had outside of the solar system 20 years ago, or we were just starting to learn. Now we've learned a lot about that. And another very recent development is the US government starting to release a lot of its information about UFOs or unidentified aerial phenomena, UAPs, as they like to call them. So that's just a sample of some of the bigger things that have changed in 20 years. So here's an update. Why did that not advance the slide? Let me try it this way. It's not advancing on this computer here. I guess I could just
go by what I see there. You want to take a crack at it, Dale?
There you
Okay.
go. Want to go back?
Yeah, I'll go back.
There you
Okay, thank you.
Mhm.
And the people online still are good, right?
Yep.
Okay. So here's an outline of what I'm going to cover today, this evening. Is there alien life, either primitive life or intelligent life in our solar system, beyond humans? Are there aliens out there farther out beyond the solar system? The Drake equation and the Seeger equation. I'm not going to make this a super mathematical thing, so don't worry about that, but a little bit. Um, uh, I'm going to address the question, can aliens travel between the stars? Could aliens get here if they were advanced in their technology? And are they here now? So that's kind of an outline of where I'm going. Regarding the solar system, if you're thinking about where there could be life, one way to look at that is where could there be liquid water? We know that can work as a medium for life because that's what we have here. That story used to be that if you are the right distance from your star, so that warmth from your star was not too great in the case of a place like Mercury, and all the water would boil away into vapor. And so you can't be too close to the fire, and you can't be too far from the fire to have liquid water, like out in Neptune and so forth, the so-called gas giants. That used to be the story. And exactly where the habitable zone is depends somewhat on planetary atmospheres. If you have a thick atmosphere, uh, that atmosphere through the greenhouse effect tends to trap warmth from your star. And so the planet could be somewhat farther from the star and still be warm enough to have liquid water. So it can be affected by things like that. But then a major discovery, uh, mostly obtained through the Voyager spacecraft, was that some of the moons of Jupiter and Saturn are covered with ice, and there's believed to be a liquid water ocean under the surface. And then Titan, the biggest moon of Saturn, is very cold, but has liquid methane on its surface. So it'd be a very, very different kind of life from what we have here. But conceivably, there could be life there. I am a major doubter of that because the very low temperatures to get liquid methane means that chemistry slows way, 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 way down. A crude estimate suggests by a factor of 1,000,000. So how are you going to develop life in that scenario? It's a kind of a situation where you never say never, but I would say it's much less likely. So that's how that picture has developed with time. We've learned a lot about Mars especially through the Curiosity rover that landed at least a dozen years ago on Mars, and then 3 or so years ago, the Perseverance rover. from the Curiosity rover, we learned the big question that was sent there to answer was, the question was not so much is there or was there ever life on Mars? The question was Mars ever habitable on the surface? That was a safe question to ask for NASA. They didn't want to get burned by trying to say too much that the spacecraft wasn't, or the rover wasn't well instrumented to study. And the answer was very clear. Billions of years ago, early in the history of the solar system, Mars was habitable on the surface. It had liquid water on the surface. Therefore, it had to have had a thick atmosphere, not necessarily an atmosphere like ours with lots of oxygen in it. But there used to be life on Earth without oxygen in the atmosphere. So it had liquid water, it had a thick atmosphere for protection from cosmic rays and all that stuff. It had the necessary chemical elements abundant on the surface, things like nitrogen and carbon and phosphorus and so forth. And it's known that it had a reasonable pH, not super acidic or super basic. So Mars, if it's true that life always starts when there's a habitable environment, Mars should have had life. Whether it still does underground now is not known. So we've learned quite a bit. This is a picture taken from a NASA spacecraft orbiting Mars. You can see dried up riverbeds. Just, the kind of evidence that there was liquid water that you can't miss, right? I mean, there it is, unquestionable. So we know that kind of thing. The Perseverance rover is still going up, exploring one of these dried up riverbeds, looking for evidence potentially of previous life. And they found this rock where some of the features of that rock suggest that possibly there was life there, but it's ambiguous. The features that are shown could have been caused, I mean, some of the real tiny little features could have been caused by bacteria colonies or something like that. Or they could have been caused by non-living processes. If you look at the scale, the arrow shows 10 millimeters. What a shame that they didn't have a microscope on board that could blow that up to like 10 micrometers. So you can see 1,000 times better, more clearly. Maybe we could have seen whether it was likely from life or not. What can you say? I mean, that's the instrument that was put on it. And all the instruments on that rover pretty much were applied to that rock. Nothing could get us a definitive answer. We don't know. There the thing is, and possibly we're looking at something that had life in it, and we can't tell for sure. What a shame. So it is a major question. Is there or was there ever any kind of life on Mars? Some kind of microscopic life. Mars was habitable for close to 1 billion years. That's a long time. That's under current scenarios of what people think about how life started here on Earth. Is believed that life started within something like 250 million years of when the Earth became habitable after it cooled off and started to have liquid water on its surface. So if Mars was habitable for anything close to 1 billion years, if life starts when there's a suitable environment, it should have started on Mars. So it's a major test to say, as we over future years explore Mars a lot more, will we find evidence of life, or at least that life used to be there, or not? And then if we do find such evidence, the immediate next question will be, is it distinct from life on Earth? If chemically it has the same kind of compounds and the same, some of our biological compounds are all right-handed or all left-handed molecules for all species on Earth. If they're all the same in that regard, for example, that would suggest a common origin of life on Earth and Mars, started one place to the other and then spread to the other. But if we find life or evidence of past life, and it's clearly distinct from life on Earth, that'd be a stupendous discovery, because that would mean here we have 2 planets in our solar system, and life independently started on each. That would give strong evidence that supporting the hypothesis that life will always start when it's a suitable environment that lasts at least a few 100 million years. So Mars is really important. And if there's no life on Mars, then that's equally a major statement, it would contradict the thesis that life always starts when there's a suitable environment lasting a few 100 million years. So Mars is quite important. Looking farther out, some of the moons in the cold parts of the solar system, surprisingly, were found to have liquid water under the ice, like Europa, and also Ganymede, possibly Callisto, other moons of Jupiter, and Enceladus, a moon of Saturn. And there's likely at least one moon of Uranus that is similar, although we have less data on it. The nice thing about Enceladus is water sometimes comes spraying, like you see there, up through the ice into space. So to sample the water that's under the ice, you don't have to go down through miles and miles of ice to get to the water. You can fly through it as it sprays up and do, instrumented studies to find out, is there anything living in that? So future studies should be very of great interest in studying them. Right now, there are 2 spacecraft on the way to Jupiter. The NASA spacecraft called Europa Clipper, if I recall correctly, should arrive in 2030. And then a European Space Agency mission called JUICE will arrive about a year later. The NASA spacecraft will concentrate on Europa. The European satellite will mostly study Ganymede. So stay tuned for more. When I look at the suite of instruments that those spacecraft are carrying, it's not at all clear to me that they are designed to look for life itself. They're mostly geological kind of instruments. Nevertheless, that's useful stuff to have. So when we look farther out into the cosmos, beyond the solar system, searching for evidence of life, what do? We don't send instruments there, it's too far. But at least we have started to find thousands of so-called exoplanets orbiting other stars, or I think in a few cases drifting through empty space, not orbiting any star. And for those orbiting a star, a small fraction of them have planets in the habitable zone of their star. So it is of great interest to study them. The way, I will get to how we will study them later in this talk. I would make the comment that if we find clues from studying them that suggest there may be primitive life on those planets, I would note that the environment not only has to be habitable now, but it has to stay habitable for billions of years to get advanced life. So it would be a major discovery if we find evidence of even primitive life, but that would not necessarily imply advanced life. So I'll talk about how we're looking, how we're studying those distant planets. For a long time, the main way that we look for life on planets outside of our solar system was to look for or listen for radio transmissions. Dr. Frank Drake, a radio astronomer, started this kind of study in 1960. So it's been, 65 or so years of those kind of studies. He was one of those who started an organization called SETI, which stands for Search for Extraterrestrial Intelligence, dedicated to find intelligent life on other planets by looking for radio transmissions. So he has been or was very influential in that area. He passed away just a few years ago, which is a real shame because I wish he was still around so I could ask him some questions. He formulated an equation called the Drake equation, and that was in 1961. He published an equation for estimating, to say calculating is overstating it, for estimating the number of communicating, I put that in red for a reason, the number of communicating civilizations in our galaxy. So his equation for that number is n equals 8 things multiplied together. And I kind of explain what they are here. The first 4 factors in that equation are things that we kind of know relatively well. The last 4 we know less well, or very, very poorly in some cases. So n equals n star, he takes the whole number of stars in our galaxy. That was a mistake. That was a serious mistake. It's the kind of mistake that nobody seems to have caught on to for a long time because there's an implied statement here that's wrong. It's not explicitly stated. The mistake is to assume if somebody on the other side of the galaxy is transmitting radio waves, that they would be strong enough for us to detect those waves all the way across the galaxy. That's wildly wrong, as you will see shortly. Wildly wrong.
And so this leads to a gross overestimate and over expectation of our ability to discover advanced life by detecting the radio transmissions, and lots of disappointment. So first factor in his equation, he starts with the number of stars in the Milky Way galaxy times the fraction of those stars that are suitable for sustaining life. For example, some stars are big and they burn out in just a few million years. No way burn long enough for life to develop. Or they have other problems like severe flaring, which is common to red dwarf stars. Times the fraction of those stars that form planets, times the average number of planets each such star possesses, which are capable of supporting life. So those are the kind of factors we now have reasonable estimates on, times the fraction of those planets down in the red zone, where life actually forms, about which we know nothing. So we rely on how optimistic or pessimistic each person is to put in their guess, which is fine as long as you're clear what the basis is for your guesstimate. It's fine to be optimistic, except if you're spending your whole career on this, it can get kind of old if you don't find anything. Times the fraction of life-bearing planets where intelligence arises, times the fraction of intelligent life-bearing planets where they develop the ability to communicate beyond their own world, times the fraction of the galactic lifetime where that capability exists. So Seth Shostak is the senior astronomer of the SETI Institute. Back in 1999, he published a series of videos that largely was on coming up with numbers for the Drake equation. I bought that series. It was on the old VHS tapes. I took extensive notes. And one of the interesting pieces of this story is he commented that, this is in 1999, he commented that he expected we would detect radio signals from an intelligent civilization within 10 years. And that wasn't the first time he had said that, but he definitely said it in those tapes. And so I checked off each year, check. 10 years came and went a long time ago. Carl Sagan had made similar statements back in the early 1970s. I think Frank Drake had made similar statements, but I can't document it. I know two people that sat in Carl Sagan's classroom back around 1973 who heard him make such predictions, one of whom used to be a member of this club. Dave, I'm drawing a blank on his last name. Dave Bailey, yeah. Sat in Carl Sagan's classroom in the early 70s and heard him say that. I heard Seth Shostak being interviewed, I think it was about 15 years ago, in a science program on National Public Radio. And he made this 10-year statement. And the interviewer said, "How do you know that? How do you know that we will have detection within 10 years?" Pinned him down, and he said, "Well, I don't know, but I hope so."
I've heard that 10-year kind of projection enough times that I think I get it. It's a long enough time period that people are going to forget. It keeps people pumped up that we're going to find somebody. But it's far enough out that many people will tend to forget it or can't remember when you said it. If you said we're going to have detection within 3 or 4 or 5 years, too many people are going to remember it. If you say we'll have detection within a few hundred years, people are going to say, well, not going to happen in my lifetime. I don't blame people who are in this business for being optimistic, but this 10-year thing, I think, is a little over the top. I don't question that they need to be optimists. It would be one thing if we had been detecting a civilization about every 10 years to say, well, we'll find another one in 10 years. That has not been the case. So the numbers, I'm not going to go through all the numbers, but Seth Shostak came up calculating that there might be about 20 such communicating civilizations in our galaxy. However, he said if, for example, we dispersed to the moon and Mars, places like that, with self-sustaining colonies, it'd be less likely that something would wipe us all out. And so the length of time we could survive might be a lot longer. Maybe there'd be tens of thousands of communicating civilizations. So somewhere between 20 and 20,000. So here's where Frank Drake went wrong and led a lot of people down a wrong way of thinking about communicating civilizations. The issue is this: if you've got somebody broadcasting signals, is that communication? Or is it only communication if somebody is close enough that it's possible, at least, for them to detect those signals? Okay? In other words, if just transmitting, even if nobody can detect your signals because they're too weak by the time they get somewhere, if just transmitting means you're communicating, then fine, you can say how many are transmitting in the galaxy. But if communication means somebody, if they have the right equipment, could, at least in theory, detect your signals, that you have to do that for communication, then most of the galaxy is too far away. So here's another diagram to kind of illustrate what I'm talking about. Here's some alien planet, the red circle, transmitting. And with distance, the signal spreads out, becomes so weak that it's undetectable. By the time it gets to the Earth, turns out if we're 1,000 light years away, which, our galaxy is 100 times bigger than that. If we're 1,000 light years away, their signals will be undetectable. Beyond that, even if it's detectable, two-way communication is essentially impossible. Suppose we're 10 times closer, we're 100 light years away. That means their signals take 100 years to get here. And when they get here, somebody had better have a big radio antenna pointed in the right direction, listening at the right frequency. And if by some miracle that's happening when the signal gets here 100 years after you send it, and they send the signal back, it's another 100 years till it gets there, right? So two-way communication is even tougher. So I was astounded some years back when I found this statement on the SETI website of all places.
They have a frequently asked questions section, and lots of questions that they ask and give answers to, buried in all that. I was amazed to find this. If an extraterrestrial civilization has a SETI project similar to our own, could they detect signals from Earth? Answer, in general, no. Most earthly transmissions are too weak to be found by equipment similar to ours at the distance of even the nearest star, which is only about 4 light years away. But there are some important exceptions. High-powered radars, for example, military-type radars, could be detected at distances of tens to hundreds of light years with a setup similar to our SETI experiments. You have to understand, when we broadcast radio programs, AM radio programs, or FM radio programs, or television, we intentionally are not broadcasting in just one direction. We're spreading out so people can hear us in all directions, right? That means those signals get weaker in a hurry. From cell phone towers, for example, the signal strength falls off in just several miles because by necessity, they have to broadcast their power in all directions. Whereas a radar, for example, is very highly directional. You send a signal that way, and if you get a ping coming back, you know where the thing is you got a reflection from. Nevertheless, hundreds of light years is the limit. So I wrote to 2 SETI scientists to ask about this. One of them, who I won't name, is the author of a textbook I use in teaching astronomy. And in his textbook, he has the same error. That when he covers the Drake equation, implicitly he assumes you can detect signals from anywhere. So I asked him, I said, here's what it says on the SETI website. What do you say? He just sent me a very short sentence, you're wrong. That's it, just blew me off. The other person I wrote to was Jill Tarter, one of the founders of SETI. And she sent me a very polite response. She said, I'm not the best person to ask this question. She referred me to this scientist, Andrew Simeon, who is at SETI, and he's actually involved in looking for radio signals. He's in the business, right? Whereas this first guy I wrote to is not. He's into, I've got a textbook, and he keeps updating it every few years. So people can't buy a used textbook for their class. They have to buy another at the latest edition. That game. So Andrew Simeon sent me a very nice response. In fact, we went back and forth a little bit. And he said the radio detection range of SETI experiments was about 100 parsecs. 1 parsec is about 3.3 light years. And he said with future improvements, the detection range will go out to 130 parsecs, which is about 430 light years. Okay, 430 light years. That's a whole lot smaller than the size of our galaxy. So I picked a picture of a galaxy with a spiral galaxy sort of similar to the Milky Way. It's also a similar size, about 100,000 light years. And I put in a yellow dot about where our solar system would be. I made that dot big enough to be easily visible. Our radio detection range would be 2 times smaller. Okay, so it'd be kind of hard to see if you're not close enough. That's it.
Well, that's our range right there.
Yeah, if somebody isn't transmitting 2 times closer than the size of that dot, we wouldn't stand a chance, and that'd be out on the edge of what we could detect. I scattered a few red asterisks to symbolically show some alien transmitters if they're out there. So the reason we have no detections to date has changed from, well, there's a lot of directions to listen and different frequencies and blah, 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 to they could be out there, but we can't detect them if they are transmitting. Okay? They could be out there. Unless they're right on top of us, though, we wouldn't know. So using for N star, the number of stars in the Milky Way galaxy is just wrong. And the correct thing to put for N star would be the number of stars within radio detection range of Earth. So I looked up the density of stars in our area of the Milky Way and compared that to the total number of stars in the Milky Way. And the number of stars in the Milky Way is nearly 1,000,000 times bigger than the number of stars within about 400 light years. So if you take calculations that I showed you from Seth Shostak, saying there might be between 20 and 20,000 transmitting civilizations, and divide by 1,000,000, you come up with statistically 0 detectable civilizations, unless somebody by chance happened to be really close. Yeah, you'd have to be real lucky. Now, another important issue that I've sort of touched on somewhat is the factor F sub L in Drake's equation, which was the fraction of habitable planets where life starts. What is the fraction? If you have in some region of space 1,000 habitable planets, on what fraction of them does life actually start? Is it 90%? Is it 1%? Is it 1 in a million? What is it? And this is not a graph I got from anywhere. It's a conceptual graph that displays whatever I know about biological evolution and the origin of life. What this graph says to me is, first, on the horizontal axis, that's time in billions of years since the formation of the Earth, 4.5 billion years ago. On the vertical axis, I put logarithm of complexity of biological molecules. So on the horizontal axis, for a long time, the Earth was not habitable. It was molten, that kind of thing. But once it became habitable, the story we have from science so far is that life started somehow. And boom, the complexity increased enormously, meaning you can find organic molecules all over the place, drifting in space and coming down on meteorites, things like amino acids and simple sugars and things like that. But those molecules have maybe at most a couple of dozen atoms in them. That has some complexity, but not that much. Nowhere remotely close to what you need for life. There have been experiments, the Miller-Urey experiment back around 1952. If some of you know, I don't have time to go into that, but you can make molecules of about that complexity. But if
using electric discharges in the right kind of chemicals. But you don't get more and more complexity with time because you start ripping apart bigger molecules as fast as you make them. So somehow a living thing formed with an enormous increase in complexity. There are experiments that have been done to study the smallest microbes with the smallest amount of genetic information in them, the smallest number of genes. And you take them and use radiation, for example, to almost destroy the organism. And you get it down to where you have a petri dish with it where some kind of bacteria has multiplied greatly, and you hit it hard with radiation until just one of them survives and starts reproducing. And then you measure how many of its genes still work. Well, 90% of its genes still work. Okay. Which doesn't prove it, but it suggests that there's a minimum amount of complexity that you need to have something that lives, and it's gigantic. So somehow there was an origin of life. Maybe it was due to random processes. Maybe it was a divine kind of act. Nobody actually knows. There's no science evidence one way or the other. But then there's a long, slow process of evolution. That part we kind of understand, I think, reasonably well, at least. I'm not a biologist, but I read their stuff. And I have a physics background, at least. A slow process. And for a couple billion years, there was only one cell life for over 2 billion years. And somewhere along, but evolution was happening. Okay? There are different kinds of one-celled life with time. And in particular, something called a cyanobacteria formed that excreted oxygen as a waste product. This is a whole new thing. And so that oxygen started oxidizing all the iron, for example, on the surface of the earth, and it became iron ore. Okay. And at some point, that had happened, and the water was pretty well saturated with oxygen, and the Earth's atmosphere started to have a lot of oxygen in it. And at some point, along about the time when the Earth's atmosphere started to have like at least 10 or so percent oxygen, there was a bump in the curve where that high level of oxygen made possible over something like 50 million years, much more complex organisms. Okay, it's called the Cambrian explosion. And then life has continued to evolve since then. So that's the story from a physics perspective, not a biologist perspective. And I say all of that just to say the factor in Drake's equation, F sub L, the fraction of those planets where life actually forms, is a factor that is pure guesswork. Okay, you can be optimistic if you want, and that's fine. But we don't know what that factor is. So another path that this search for intelligent life has taken is to look for not just radio transmissions, but laser beam transmissions. Why would people think that would be a thing to do? It's because the shorter the wavelength is, the more you can, I'll use the term, focus it. So it's just traveling in more like one direction. So then it remains a intense beam for a longer distance. Okay. So the wavelength of light is, several factors of 10 shorter than the wavelength of your typical radio waves. So you can potentially detect laser beam signals from a lot farther away. The problem is the star that a planet's orbiting is typically giving off a lot of light in the same wavelength range. So it's not as big of an advantage as you might think. But anyhow, it's worth looking at. And I have followed these two authors. I think they're at University of California, Berkeley. And they've published a number of papers over the years looking for laser signals. This is the last paper of theirs that I can find from 2024. They say in their abstract, we searched the Milky Way plane along a 6-degree swath for pulses of monochromatic light. That means laser light. So if here's the band of the Milky Way, they looked for a path 6 degrees wide and along the band of the Milky Way, just looking for any laser beam signals. No unexplainable monochromatic emission, pulsed or continuous, was detected. Previous searches for laser emission from more than 5,000 stars, I've got that paper of theirs, where they picked stars specifically similar to the sun, found none. And they conclude this: hypotheses of our Milky Way galaxy teeming with advanced life must be demoted. This comes from people who for many years have spent their professional life looking for this kind of signals, right? So they're kind of on the positive side or they wouldn't have spent several years of their life looking for this. That's their conclusion. So that moves us from that's kind of the story of looking for evidence of intelligent life, looking for either radio transmissions or laser transmissions. Therefore, some fraction of the effort going into this has switched to looking for evidence of primitive life. The Earth had primitive life for a long time. We've only had radio and laser technology for several decades, a century in the case of radio waves. So, better chance. I mean, there could be a planet, 100 light years away that is still at the stage where all it has is primitive life, no intelligent life, and it could stay that way for billions of years. So don't hold your breath waiting for them to become intelligent, right? If you can detect even primitive life, that would be a major discovery. So that has led to studying the atmospheres of relatively nearby planets to look for evidence of a composition of an atmosphere that would suggest there must be life. Like if you see a high concentration of oxygen, that would be a strong, it wouldn't prove it, but it would be a strong indication that there might be primitive life. There are non-living processes that can produce oxygen, probably not 20 or so percent like we have. So it's very difficult to do those studies, but it's being done now with the James Webb Telescope, spending a fair amount of its time doing those kind of studies. So far, no encouragement, but those studies are still at an early stage. So we'll see. Sarah Seeger, a professor at MIT, wrote the Seeger equation, kind of analogous to the Drake equation for finding primitive life this way. She restricts herself to 30,000 stars that are nearby because it's very difficult to do these studies to get a strong enough signal. And she assumes in her equation that if a place is habitable, the chances of life starting are 100%. So she's being as optimistic as she can be. That's all right, as long as she's clear that that's what she's doing. So she estimates that we should be able to discover evidence of life on 2 planets within 10 years. Okay. I think it's been about 12 years now since she said that.
Say, Dale?
Yeah,
The FHZ in Neil deGrasse Tyson's Death by a Black Hole, he said that with the discovery of extremophiles and the geysers in Enceladus and ocean worlds, the habitable zone could be the entire solar system.
yeah. Could
So
be.
that is a 1.0 for that value.
Well, you can put it whatever you want it to be. Um, to go from 0.15 to 1 is what, a factor of something like 7. So 7 times 2 is 14 planets. Fine, whatever it is. So that's another direction of research. And it's a relatively new thing that we've got a telescope with the James Webb that's good enough to do that kind of study. And there's this gigantic, it's called the Extremely Large Telescope that the Europeans are building in South America. That will help a lot because the signals are so weak to do this study. And unfortunately, I have to look through the Earth's atmosphere, which will be a complicating feature of that. But you do what you can do. So that's a picture of that telescope, scheduled for completion, I think, early in the next decade. Can aliens get here? It's one thing to look for signals from aliens, but how about they come here, right? Could they come here if they wanted to? So how am I doing on time? I think,
Actually closing it on 9 o'clock.
okay, I'm gonna kind of, yeah,
Quick question. Has anyone ever thought just abandoning the whole chemistry with that stuff? Thought about looking for energy using T-rays?
what was the last thing you said?
Because you look at chemistry, something from water, etc., regarding life. Have they ever thought about looking for energy?
Sure, they've thought about looking for energy. That's what you're doing when you look at radio signals and laser signals. You're looking for energy.
I was going to sweep for energy for life. As far as I'm saying, because all life is energy, all existence, right? But it seems like everybody's trying to study why extraterrestrial life always concentrated based upon chemistry makeup of what we think life is needed, what is needed for life.
Well, what form of energy are you talking about?
Not sure, but you can look for like in a scale, like in a THZ range.
Well,
like some kind of like energy.
what I'm saying, look, there are only a limited number of ways to look for energy that I know of. One is to look for the energy of radio waves that they're transmitting, or laser waves that they're transmitting, or if you want to go to extreme cases, if a civilization is harnessing most of the energy of their star, that would affect what you would see, the kind of light coming from the star. So people, yeah, they're looking for energy, but they ain't finding it in terms of evidence of intelligent life or even primitive life. If you look for the energy in the light passing through planetary atmospheres, that can tell you what chemicals are there. I'm going to skip this part of my presentation and I'm going to cut to the chase and say it appears to be real tough to travel between the stars. The amount of energy you would have to put in a spacecraft is incredibly large if you want to get here anytime soon. Our fastest spacecraft right now to get to the closest star, you'd be talking about close to 100,000 years of travel. Okay. And if you want to send people to get them going really fast, it would take
The light still isn't going to do anything for you.
yeah, well, the problem is by the time you're even up to half the speed of light, if you hit a tiny pebble like this size, it's like a nuclear bomb going off. Even hitting a microgram particle of dust would be like a dozen sticks of dynamite blowing up.
And you'd be weightless for many, many, many years. That's devastating. Huge radiation exposure. And you have to slow down when you get there, which is non-trivial. So, are aliens here now? Regardless of how they got here, right? Are they here? So some people look at the pyramids or Stonehenge or Göbekli Tepe involving monumental building projects, and they say ancient primitive people could not have built such things without some kind of aliens building it or telling them how to do it. That's just wrong. People have figured out how they could have done it. And people that lived 5,000, 10,000 years ago were just as smart as we are.
Yeah.
It's kind of a, I don't know what the word is, but it's we're greater than we think we're greater than we are kind of attitude if you think they could not have done it.
Of course.
Again, I'm going to skip some stuff. Let's talk about UFOs and unidentified flying objects, or UAPs, as they're sometimes called, unidentified aerial phenomena. There's a physicist named Dr. Hugh Ross. He's actually an astrophysicist who has studied UFOs for something like 50 years. And he says 99% of UFOs, if you study them, they have natural explanations, or they're hoaxes, or they're secret military things. The other roughly 1% are the interesting ones. And sometimes they defy the laws of physics. If you look at the kind of things they're reported as doing, objects sometimes traveling at hypersonic speeds, like 10,000 miles an hour, but no sonic boom. And then they'll just make an abrupt right angle turn, which would be absolutely lethal to any flesh and blood creature on board. The G forces would be off scale. And military pilots have for some time reported seeing such things. Looking at, I mean, I've waded through a lot of the stuff that the US government has been making publicly available. A lot of it is not very conclusive. You know, you see this dot on a radar screen and moving around. What is it, you know? So I picked some of the more interesting things. This is a sketch or a painting made by a forensic artist of an unidentified object. I'll next show you the FBI report that sketch was based on. Let me get my glasses on here. Maybe I can read it here. Back in 2024, at 11:25 in the morning, a former U.S. Army intelligence officer, along with 4 other members of his unit. So you got 5 rather credible witnesses, right? Observed a unidentified aerial phenomena over the Cheyenne Mountains in Colorado as they exited their office building. Nice clear sky. The object they saw was potato-shaped. I just saw your drawing of it, with distinct edges, appeared to look painted in a creamy, whitish, opalescent color. You can read some of the rest of this stuff. After approximately 2 minutes, the object vanished. Just bam, it's gone. They said that the object cloaked itself, is the terminology they used. So I'll show you the sketch again briefly. That's what they say they saw. Or here's a married couple This again from the FBI. Two orbs, ORBS. You can kind of see them in the trees, one above the other. Estimated distance 75 yards. The two witnesses were extensively interviewed by FBI agents. They were assessed by the FBI as credible. They recorded video, 2 or 3 minutes of video. I just show you a still image on their iPhone. Interestingly, this observation occurred in a somewhat remote rural type area in the northeastern United States. And there have been some other sightings of similar things in that same general area. Okay. So I don't know why they seem to want to keep coming back to the same spot or area. So I refer to those as slow movers. Okay. To distinguish them from some fast movers, I'll show you. So here's another one that I looked into quite extensively. Experiences of the Bledsoe family in North Carolina. I think this one is quite significant because they've been seeing these orbs since 2007. And hundreds of people have gone there and seen them. They're not there all the time, but they come reasonably frequently. Lots of pictures and videos. I wish I could show, I've got the link to this video. This is just one frame of it showing you all these orbs. And if we can't get the video in past the firewall of this place. If somebody wants to see the video, I can send you this, or if you watch the YouTube video of this, you can probably read the link. But you can hear as well as see, and you can hear all these people talking. And then somebody's got a green laser pointer pointing around. And it just gives you a sense of the reality of these things, okay? And they're moving around. Federal government officials from NASA and the FBI and so forth have been there and looked at these things. And sometimes those orbs land and these strange beings come walking through the woods of these people's property. This is a painting of what they look like. They're about 3 feet tall, humanoid with red glowing eyes. They have a triangle on their chest. And if you get too close, you can get negative health effects. Chris Bledsoe, the father of this family, claims that these are spiritual beings, not physical aliens from other planets. I note that he is involved with the occult. And I will tell you that statistical studies by Hugh Ross indicate that people that are involved with the occult are much more likely to have particularly close encounters with things like this. For example, in Brazil and France, the per capita incidence of people having close, nearby encounters with these kind of things are much higher than in the United States, and people are much more involved with the occult there. Chris Bledsoe's, one of his teenage sons woke up one night. He was laying in bed. One of these things was stroking or feeling his legs. He started screaming and ran into another part of the house where his parents were. Another time he woke up and he could see the red glowing eyes of one of these things looking at him from under his dresser. They seem to be able to move through the wall, to come into a house and leave without needing a door or anything. I am feeling conflicted about whether to tell you this final thing about that or not. With apologies for some people that won't like it. They've learned to say the name Jesus, and it drives them away. I'm sorry if that's offensive, then
What happened?
if they if they say the name Jesus, it drives them away. Sorry, Ken.
Sorry,
Um,
I'm not surprised.
anyhow, talking now about fast movers. Um, there's a video that just came out recently of a Hellfire missile being fired. I think this is over Yemen in the Middle East. Yemen, however you say it. They saw something, a fighter pilot, or actually, I think it was two unmanned drones, or one of them was a fighter pilot and the other was a drone. One of them fired a Hellfire missile at one of these things, and you could see in the video it hit it, but it didn't explode. And there's a congressional committee where you can see this being taught, the video shown, and they're talking and say, how could this be? Those missiles work real well at blowing up when they hit things. And here's another video where they're tracking one of these things, traveling at high speed. There's a lot of videos like this. And the problem is you can't see what it is very well because they're not close enough. But they see a lot of this stuff. What? And now that the government has told its military to turn in reports when they see unidentified aerial phenomenon, as opposed to making people feel like they should keep their mouth shut about it. We're getting over 700 reports last year, for example.
That's right.
So that's important, even if they can't see what they are in most cases very distinctly, because you can get statistical information then. There's a video, I've got the link here, US F-16 pilot. He's now out of the Air Force recently, but he's making videos about various things. He goes by the name Max Afterburner. And he's seen UFOs different times. One of them, this is a painting of what he saw flying next to him, 40 feet in dimension. You know, at high altitude, reasonably fast. How could something like that do it? You know, it's not aerodynamically shaped at all. He doesn't know what it was. And then he has another video where he discusses what a lot of military pilots are talking about, which are these things, or at least a lot of them, are they secret military things, or are they something alien or whatever? In this case, there was a 60-foot long UFO that zoomed from 80,000 feet, which is really up there, down to sea level in seconds, and then just stopped. Had no sonic boom, no heat trail through the air, and these kind of objects can just disappear like that. So here's the end of the story tonight. We're left with some big questions. Are these things, in some cases at least, advanced military aircraft? That last slide I showed you, he talks a lot about whether Lockheed Martin has maybe they've recovered some crashed vehicles and they're reverse engineering them and making some new kind of stuff for our military. Are these flesh and blood type aliens? Are they interdimensional beings? There's some people who speculate about that they can materialize into our dimension and then slip out in another dimension. Are they spiritual beings? In which case they could do something similar to that, presumably. Whatever they are, if they're not military stuff, where are they from? What are their intentions? Why are they making themselves visible? I've crossed the border where I think there's some reality here. And I don't think it's all military stuff. Some of it likely is, okay? I know some of it is from previous history. but not all of it, I don't think. So who are they and what are they? How much more does the US government know that they haven't disclosed yet? I think it's a major question. That's at least one piece of the story that probably we're going to learn more over the next few months. So that's pretty soon. They've had 3 data dumps over the last, I don't know how many months, several months. So if they keep going at that rate, we'll be getting more soon, not 10 years from now, maybe within a month or 2. So I think that is kind of interesting. And that's my story. Thanks for listening. Yeah.
Let's see, Roswell, crash, little gray humanoid thing. Was that real? And what does that prove?
Was that real and what?
Roswell, was it real and what does it prove?
That was in North Carolina, where those little short things with the red eyes happen. They've been there different times.
He's talking about Roswell with
Oh, yeah, there have been claims for a long time that back in, I think, the 1950s or 40s or something, there was a crash. There's an Air Force general who released a statement in a local paper just days after that that said the rancher who found this supposed crashed spacecraft, what it was a weather balloon and equipment. Whether that's a cover story or the truth, I don't know. I know if you go to Roswell and you want to buy some pieces of spacecraft, they're for sale.
Okay, support it. But again,
We really gotta get out. One more question and a comment.
And I'm planning to go to the restaurant, so if people want to come there and talk more, we can. Yes.
You have a dot on top of the galaxy. How many exoplanets are on inside that dot in that radius?
You're talking about the little yellow dot?
Yeah, known exoplanets that we know today.
Oh, known exoplanets within that dot?
Yes.
I mean, we only know a tiny fraction of the exoplanets that are out there because I'm not using the transit method for detection, which is the most prolific way of finding them. Unless they happen at their orbit passing exactly between us and their star, we won't see them. I mean, we have 6,000 confirmed exoplanets, several thousand more.
That's the whole solar system. A lot of them are,
So
far away.
what exactly is your question again?
How many are inside that dot that you put on the?
There are hundreds of confirmed exoplanets located within a 100 light year radius of Earth.
So,
And so hundreds are known exoplanets. That means there are about 1,000 more than that.
Okay. So there's hundreds.
Thousands.
Lots, so.
we have to get out of the room.
Yeah.
Okay.
Again.
okay. Look, first of all, you have to understand the universe is 13 billion years old. Understanding that we've only been on this planet for 100,000 years, maybe a little bit more, because of human time. The fact is, I believe that life is endemic to the universe. The universe is made up of the same elements, so the life forms, in order to be complex, have to be carbon-based. Okay? And the point is that they get to be intellectually more advanced than us by a billion years. They may be able to cure death. They may be able to do all the things that you have, but they're going to, any life form you find in the universe is going to be less related to you than you are to a blade of grass. We all come from the same stuff, it's still carbon-based. But your life in the universe is probably endemic. I don't have a problem with them coming here, and why would they want to stop here? Have you noticed what we do on this earth to each other? There you go.
Okay, well, I think we gotta stop there. Thanks, Ken.
Thank you very much, Dale.
Yeah.
Some odd years, so.
If you can, please join us at the Red Coat Tavern immediately afterwards. It's located on Woodward, just above 13 Mile. So we can continue the conversation there. Thank you, everybody. Have a good night.
That's my story.